In this example, we have ourselves a couple of 3 by 1 matrices. So each matrix has 3 rows and a single column, 3 rows and a single column. And they are equivalent matrices, which means that their corresponding entries are going to be equal to one another. So it looks like we have a couple of variables, m and n, and I would like to find the values for m and n that make this equation true. So since they are equivalent matrices, I can go ahead and set these corresponding entries equal to each other and then solve the equations. Okay, so it looks like in this first one, and by the way, these 3 equations just came from 3m equals negative 15, this negative 9 equals m minus n, and then this last row, n squared minus 1 equals 15. So it's just these corresponding entries that I set equal to one another. It looks like this first one's pretty easy. I can just divide both sides by 3 in order to isolate the m, or solve for m. And it looks like m is negative 5. Well, okie dokie. So if I go ahead and take that negative 5 value and plug it in right here, then I'm just left with solving for n. So let's go ahead and add 5 to both sides, and it looks like negative 4 equals negative n. So that means when I divide both sides by negative 1, 4 equals n, or of course n equals 4. And let's just go ahead and ensure that it works out for this final equation, n squared minus 1. So 4 squared is 16, minus 1 is 15. So this does work. So we're saying then that m equals negative 5, n equals positive 4. So let's just go ahead and plug it back into the first two, because we already plugged it into here, we know it works. So 3 times m, so 3 times negative 5 is negative 15, that's good. And m minus n, so negative 5 minus 4 is indeed negative 9. So we're good to go on this equation here. We had a couple of equivalent matrices. They had the same dimensions, so I knew that their corresponding entries were equal. So I set up my equations and solved, and then went ahead and checked my answers. And in this case, the value of m is negative 5, and the value of n is positive 4.